So we're on to topic 8, fantastic. Just notice this is both info processing and feedback, and we want to be able to obviously have a sort of clear understanding of both. Feedback is part of the information processing model. I'll come back to that. Explain how knowledge of performance, which by the way is a type of feedback, so we've got to pick that out from our question, would help a young girl who is learning a BMX trick, a new BMX trick. So obviously we've got a BMX trick being done here. This was originally a video. We'll use it as a still at the moment. But what would we expect the answer to be here? The performer does not yet know what the skill should feel like. Now, this I'm just gonna dwell on this for you. What the skill should feel like. Now, you can use the term sort of kinesthetic feel if you want. Feel like. Now, why doesn't this performer know what the skill should feel like? Why? Because it's a new BMX trick to this particular performer. Now, it's given us another hint because it's a young performer. Maybe they're just starting out. We're assuming that. But the point is, this person doesn't have that kind of intrinsic feel, that knowledge of performance, because they don't know yet. They don't know yet how the skill should feel. So the knowledge of performance would help her make changes or spot strengths and weaknesses. So it could be, for example, strengths and weaknesses. It could be, for example, that our performer uses some kind of video playback as a knowledge of performance, strengths and weaknesses. By the way, that was meant to fill into that gap as well. Because she is focused on the process, not the result. The process, not the result. Not the result. Making errors is not negative for her. So let's just dwell on this for a second, folks. We're saying that that how she can use knowledge of performance is, well, she can't do it from the feeling of the skill. So the knowledge of performance, let's say some video analysis, would help her to spot her strengths and weaknesses. Maybe she's not got enough pace. Maybe she's got too much weight on her back wheel or something like that. Because she is focused on the process, not the result, not whether she landed it perfectly, but how well she actually performed the skill. Making errors is not negative. And of course, errors is one of the best, in fact, some of the most golden feedback that we can get in a sports performance kind of environment, because of course it gives us specific information about how to improve. Now, let's just move down here. I just want us to make sure that we are confident on the differences between a knowledge of performance and a knowledge of results. So, knowledge of performance, or obviously what we refer to as KOP or COP, what we're talking about here is technique, tactics, how successfully a technique has been performed, so technique again, and how well someone's played. So notice this is not about winning and losing, first place, second place, in and out. No, this is how well the skill was done. Whereas, and there's my comparative statement right there, our core, our KOR, our knowledge of results is feedback about the outcome, the score, the result. Did the ball land in, out? Was it received or missed? Imagine you throw or hit or kick a pass in the different games you might be playing. Was that pass received? Was it missed? Was it caught? Was it dropped? These are all, folks, all of them are results. A knowledge of results, often which come after a performance has occurred, can also give us information. Now, we're not trying to trade these things off. We're not trying to say one is better than the other. We want to have performers with both. But one thing I want to stress to you, this one is less controllable than this one. I want to be clear here. Performance is more controllable than results. Now think about that. You can control whether you perform well. You can't control whether you win or lose because someone else could play better, right? So that's just an interesting kind of little motivational angle take here. Now, what if the question above were asked in relation to KOR? So let's have a think about that. We've got the question here. Think about what a young performer would do in terms of knowledge of results, okay? So we could go about saying, okay, one of the things they would do is they would have something like the outcome of the performance. Now that could be in different ways with BMXing, but one of them was it landed or not? Was the actual jump, the trick landed or not? That would be a form of knowledge of results, and that's one way of thinking about that. It could also be that she uses some kind of judging, because obviously BMXing, the type we're talking about here, freestyle BMXing, is done through a judged scenario. They could use some kind of judging as to create that knowledge of results. Okay, so that knowledge of results. So it's going to be something objective, such as did she land it or not. It could be something slightly more subjective. What would a judge kind of score it? And that would be useful to give context. But also remember, if you only had this and you were doing something new, this could have motivational issues for the performer. Okay, because it would be likely that the performer would definitely make mistakes. Errors would be seen as weaknesses in this case. Scoring differences, didn't land it or whatever, that would be seen as weakness. Now, what I want to do here is I want to go down to this answer here. So we've got this question here. So we've got a question here. Using a sporting example from a games activity, explain each stage of the information processing model. Now, we've already got the stages: input, decision-making, output, feedback. I'll just draw it in for you. You'll have seen this before, but here is our input. We then, in our model, go to our, I'm just going to call it our DM, our decision making. We've then, in our model, got our output, actually producing the skill. But of course, the thing that loops back round is that idea of feedback. So our information processing model is like that, and we've obviously got it in our framework. So what would we have here? What would be potential answers? Now, if you look what our student's done here, the student's been answering this question. They have circled the word explain, that's what our student has done, and they've decided that their example is a tennis return. Okay, a tennis return. Look at that second word, return. It's a tennis return. So this student is considering, look, a tennis player, perhaps in training, is returning serve. So what would be the input for this? This would be things such as the flight. This would be things such as the speed. This would be things such as the trajectory, the arc, the angle, and even the spin, because some serves are hit, of course, on the ball as it's served. So one of the things I want you to realise here is that input is all of the sort of circumstantial sensory information. This is very sensory. Like, we perceive the flight presumably through sight, and the speed the same, the trajectory the same, and the spin we're using sight and vision to bring that information into our system. Now, the decision making is what we're going to do in response. Receiver interprets the information, ignores some of it. By the way, this is what we call selective attention. If we ignore some of the information from the input, or sometimes called the display, we call that selective attention, and decides to what? Well, our performer is decided to step to their right, and make a block forehand return, a block forehand. So the point I want you to realize here is all they've done is decided to do this. It's not creating that movement. It is the decision, and we do this by comparing the information, our short-term memory to long-term memory. They've decided to do this. The output stage is when it happens. How? Because the nerves in the body stimulate the muscles. Now, that is pretty much always going to be the case to produce a sporting movement, stimulate the muscles. So the point I want you to think about with the output is this is literally the movement. The nerves stimulate the muscles as the effector mechanism of the legs and arms to move right and block the serve. And finally, folks, the feedback aspect of this, it is the feeling. It's the feeling. By the way, the reason I paused just then is that someone was sort of waving at me frantically, so I thought there was something wrong, in case you're wondering. But the feedback is the feeling of the quality of the contact, the quality of the contact of the ball on the racket, on the racket. I haven't got space for this. On the racket. There we go. On the racket. And knowing whether or not the return landed in. So can you notice with my feedback, what type of feedback have I got here? I've got both. K-O-P, the feeling of the ball on the racket, and I've got K-O-R, did it go in or not? That's what we're referring to. Now, the other thing I want you to be aware of here is that WJEC could make that kind of question 6 marker, and the way they would do that is they would say to you something like, analyze the different phases of the IP, which is information processing model, in relation to an example. So the point I want to make here in relation to an example, so maybe it would be a tennis return, for example, but the point I want to make here is notice what this question does differently. It is a 6-mark question. Why? It's a 6-mark question because unlike the one we just did, the different phases are not provided to the student. So you could get a 6-mark question very much like this, but without that sort of framework put in around the student. And that's something that I would encourage you to consider. So let's have a look at one of our big topics here, levers. And it's a topic I think has a tendency to confuse students when maybe it doesn't need to. Let's have a look. Question 20 for our national mock exam. 2 different lever systems occurring at the shoulder and ankle as the badminton player hits the shuttle. We simply need to identify them. Now I'm going to start with the ankle first. I feel like it's a more obvious one to most students. We know that the ankle, when it plantar flexors, which is what's happening here, this, folks, is a 2nd-class lever. And the reason it's a 2nd-class lever is because the load, or sometimes we call it the resistance, is between the other 2 components, the fulcrum and the effort, okay? So I could actually draw that in for you, but here's the lever arm here, okay? And we've got the fulcrum here. We've got effectively the load of the body here acting down through the shin, and then the gastrocnemius is pulling behind the leg, obviously. Up there is the effort. The load is in between the other components, therefore it's a 2nd-class lever. Now the shoulder is actually a tricky one, the shoulder. It actually varies a little bit. I'm not going to get too much into it. But the shoulder is a 3rd-class lever system. Now I will tell you that this is because the obviously the effort is in the middle in this particular case. So I could draw it out for you here. We've got the lever arm here. Obviously we've got the load at the end. You know, that's the load at the end. Let me just change color to make it a little bit more obvious. Here we've got the lever arm. We've got the load at the end. We've got the fulcrum here because it's the shoulder joint that's moving, and of course the actual deltoid is inserting here onto the humerus, and that's the effort. So the effort is in between the other 2 components. It makes it a 3rd-class lever system in there. Okay, let's take things a little bit further. Look at this question for the 29 exam. So this is from the real exam in 2019. Geraint Thomas, one of our absolute favourites. Geraint Thomas became the first Welshman to win the Tour de France. Well done, Geraint. Top effort. Identify the classification of lever at point A and point B. Well, point A here, we have the neck. It seems to be pointing a little bit to the shoulder, but we'll go with the neck, because that's what the table tells us to do. And the neck, folks, is a 1st-class lever system. It's a 1st-class lever system, and that is because it has the fulcrum in between. And the knee joint here, this is a 3rd-class lever system. Because why? Because it has the effort. Yes, it has the effort in between the other 2 components. Now, what would we say? How would we go about assessing the difference? Well, we would say here is that 1st-class systems have the fulcrum between the other 2 components, comma space, whereas, because I'm sort of saying what the difference is, whereas 3rd-class have the effort in between. And that's how we'd assess the differences. Now, you could take it a bit further in different directions. So, for example, you could be talking about the relative kind of mechanical advantage of the different lever systems, but this would be sufficient for us to pick up our marks. Okay, let's have a look here. Select a lever from the 4 options above that operates at mechanical advantage. So I've got a 1st at the elbow when we've got elbow extension. We've got a 3rd-class at the knee when we've got a knee flexion. We've got the 3rd-class at the elbow during a bicep curl. We've got a 1st-class again at the elbow with elbow extension when she throws in this direction. And we've got a 2nd-class at the ankle at the takeoff. And of course, it is here our plantar flexion, or we've got the jump. If I put in here the jumper and say the jumper's ankle, and let me show you why this is the case. Okay, so if I just draw the lever arm in, the lever arm is here. Okay, so excuse me for being a little bit scrawly with my writing. Here is the fulcrum. That, of course, is that's where the foot contacts the ground. We have got the load, which is the bit that's going to be in between. That is here. That's the load, and it's the weight of the body acting down through the tibia. And the effort is the contraction of the gastrocnemius, which is there at the back, okay? So we have got the load is in between the other two. Now, the other thing I want to make is, so it's clearly a second-class lever, that's what we mean there. But the other point I want to make to you is that the distance between the effort and the fulcrum is greater than between the load and the fulcrum. So the reason that is, folks, is because we have got a longer effort arm. So in other words, the distance between the effort and the fulcrum is greater than the distance between the load and the fulcrum. That gives us a mechanical advantage, okay? Explain why you chose this. So we have got the effort, we have got the effort arm. Let me write this in properly. The effort arm is longer than the load arm, Brilliant. This means, and by the way, I should have paused at this point. Notice that we say explain why. Because the effort arm is longer than the load arm. This means the ankle can what? Lift heavy body weight. Now, obviously, I'm not suggesting that person has got a heavy body weight, but bodies are heavy by definition. Lift heavy body weight during the jump with relatively little effort. And of course, that is an excellent description for us of the concept of mechanical advantage, and that is almost like a textbook kind of definition for us. And we find them where? At second-class levers, which we use the classic example of plantar flexion at the ankle during something like a jump or a takeoff. Okay. Let's keep this thing rolling. One principle of, obviously principles of training we're doing here. One principle of overload, well, of course, we're going to talk about frequency, intensity, time, and type here. So I think the one I don't know why, but I always think of intensity when I think of a principle of overload. By all means, put frequency, by all means, put time, by all means, put type. But for some reason, that's the one that sticks in my mind the most. I don't know why. It's the only one that's a vowel. Not sure what difference that makes, but have a look at this. Describe how a young netballer can use 3 principles of training to improve performance, and they are specificity, progression, and variance. Now, again, guys, I realise I'm going to make you watch my writing here, but I do think the importance of modelling this for you is there. So, to make it specific, let me just bring this down a little bit. To make train specific in netball, we make training relevant. We make training relevant, and how we're going to do that. And we're going to say here, 10 netball by, and I'm actually going to underline that word, by incorporating skills into circuit training. So imagine, for example, that we set up a circuit and it was 4 netballers. It's quite probable that we would do some kind of footwork drills within that circuit that mimic the footwork that's required in netball, for example, or even it's got some passing, and you could even look at like the chest passing technique, for example, and do some kind of chest passes with medicine balls. Say, we can incorporate skills. How do we show progression? We want to make the challenge more, or I suppose a better way of writing that would be to make it more challenging, wouldn't it? That would be a better way. Make the challenge more difficult gradually. Okay, now that word is really important there, gradually, because one of the things we mustn't do with progression is do it so rapid that it breaks the principle of kind of reversibility. Effectively we do too much work, cause an injury, cause boredom, cause demotivation, and then we end up kind of having to having to drop out. And we do this by, there's my underlined word, lifting heavier weights, or running for longer weights or running longer. So in other words, if you step back from what I've just written there, I've said that we can lift heavier weights, that's the intensity of overload, run longer, that's the time of overload, that's what we mean. Now variance is another one we've got here. What do we want to achieve? We want to maintain motivation. By the way, the noise around me is outrageous. I hope it's not too disturbing for you. There's my underline again, by using a range of methods. So we don't just use one training method, we might use a range of training methods, such as circuits, which we mentioned above, of course. Let's say weight training, which we've kind of mentioned slightly because we talked about the increasing the resistance, and continuous, which we kind of mentioned already because we talked about running for longer. Now guys, just want to mention something here to you. When you explain how to do something or describe how, it's pretty likely you're going to use terms such as by. You do it by, you do it through, you do it via. The way to do this is. That's what we mean. By is a really good sign that you are saying how something happens. Just remember, other examples are through, via, by using, by doing. These are all, they're the use of by in that case. These are good examples. If we go back to that command there, folks, what did we have? We had that how word in there. So when we're describing or explaining how, it's pretty common you'll be using the by word, and that's just a bit of guidance. Now look at this question from the 2022 exam. Identify 2 ways a marathon runner could overload their training program to improve their anaerobic threshold. Okay, so it's interesting, this one, because it gets us to think about marathon runners. So it's like long duration, low intensity, but then we've got anaerobic threshold. So this is ultimately what this means is they're trying to work as hard as possible without going into that like lactic acid buildup, okay? So the first way I'm going to say here, let me choose it. Let me go back to black just to its exam looking kind of thing. We're going to say here, increase intensity by, obviously there's my by again, by running at 85% heart rate max instead of 80%. So there's one way that we could use. Okay, so I'm saying basically have intensity go up, and that's how we would overload in order to do this. Now, obviously, we could look at type. We could bring in other training methods. We could look at something like frequency. In fact, I'm going to do something. I'm going to increase frequency. We could have done sort of that run for longer for time, right? By training 4 times a week instead of 3 times a week. And the reason that is the case, guys, is because if we, and again, I just want to highlight for you, if I just choose my green again, just look at this and this. There's a real theme here, isn't there? And again, if I just go down here, these are our principles of training: specificity, progression, overload, variance. And notice here that what we can do with our overload and progressive overload is we can overload using frequency, we can overuse using intensity. I've just described those. In our case there, we could have said, this person's going to run for an hour 30 rather than an hour 15. And type, it could be that you're going to incorporate some interval or some fartlek training as well as continuous training to increase the variety, increase the type. But obviously we don't want to overtrain, and we don't want to cause boredom, injury, and we don't want to cause demotivation, or burnout is a nice way of describing that. Now, I used the term reversibility earlier. I should refrain from that and talk about the dangers of overtraining. We often talk about this as reversibility with lots of different courses. Okay, so that's why it slipped out of my mouth there. But dangers of overtraining, what we mean there is we can't overtrain. We don't want to do too much. Why? Because we get bored, we get injured, we become demotivated. As a result, what happens is things like frequency drop, things like time drop because of that, and that's obviously something we want to avoid doing.